Alright, so in today's video we're going to take a look at one of these two chargers. And this entire video comes as a result of me getting a very cool gift from my girlfriend. And that is this kick-ass thermal camera. And what you can see is one of these is actually quite hot. So if we enable the center spot, we can see it has this, what is it? So 32 degrees. The thing is, the other one is totally cold, sorry. Super ambient, absolutely no quiescent draw. This one, right, initially I thought the cable was at fault. So I have two cables going to both of these. And I made all these iPhone cables have a little chip inside that talks with the iPhones and tells them they're legit and whatever. So maybe that one had an issue, but no. Even with absolutely no load, this one is frying up. Well, it's not frying up, but it is what? Ambient is 27 and this is 32, so it's 5 degrees above ambient through the case, so not really cool. These are both from, I don't know. I mean, at least one of them, I think this one might be from the flea market. I did check it for authenticity, so to say. Let me turn the light on and we can have a look inside. So they have a little serial number over here. Let me see if I can shine the light at the right angle. Alright, so they have some scribblings in there, and all the fake ones also have the scribblings by now. The edges are not super perfect. It's a bit cracked, but some of these do crack if you mishandle them or hit them or smack them, or if they just get old. Designed by Apple in California. FLEXTRONICS. I don't know, it looked legit enough, right? And these are pretty hard, so yeah, let's see the other one. So this one is also FLEXTRONICS, and one of these is definitely mine from back in the time when iPhones did come with chargers. I was back in the Stone Age, and you can see the connector is a bit more flush, I suppose, right? It's maybe better, I don't know. And this one also has a serial number in there. Roughly the same, but again, yeah, if we want this to look faker, it does definitely look more fake, but I don't know. And I do remember having actually done some noise tests on these. So before we take it apart, let's actually have a look at that. So for this, I'll be connecting a passive resistor bank, passive load. Let's see. All right, so under no load, we get about 60 millivolts, and I'm not doing this 20 megahertz noise measurement, which is super standard. I'm just letting the scope go with the full 100. Frequency, I don't know. So if we trigger on the higher stuff, it's a few megahertz, I don't know, it's fine. So 60 millivolts is very good for noise floor, and let's load it down to 1 amp. We get a little voltage drop, so it's a bit under 5, but still pretty okay. Noise has gone up to 65 or so, so it's still very good. And if we exaggerate to 1.2 volts, get a bit of a thicker noise content, but still under 100 millivolts peak to peak, so that's quite acceptable, right? And it's, yeah, it's looking fine, to be very honest. Alright, I'm not bothered by this at all. Yeah, so this is looking fine. And let's take a look at the other one and see what that does. So this would be the the more efficient one, let's just call it that. And yeah, let's zoom out a tiny bit. Bit of a different profile, so also about 50 millivolts. Let's load it down to 1 amp. And we have a bit more voltage on the output, so it's, yeah, I guess it's looking more original, right? So it looks like it has a better feedback loop. 65 millivolts, same noise figure, right? The glitches we're seeing, I think, are just the cable moving. And it is different, right? Now let's load it down to 1 point something, and this one does drop to 4.5 volts, and it does look different. Noise wise, similar, but less spiky, right? Let's go to the other one again. Yeah, so this one has these very sharp spikes. The other one was a bit more, right, had them smoothed out a lot more. So yeah, I suppose the one we're about to tear down is fake. That being said, let's tear it apart. Alright, so yeah, dude, this doesn't look fake. We have the classic way these are made with these two pins just contacting some posts on the board. So this looks fine, to be honest. Looks very high quality. All right. Okay, and now, boom. FLEXTRONICS charger, let's see. Oh geez, I don't know. So what we could do now, I don't think I've damaged it enough, is just give it a good clean. And we can zoom in and see what actually heats up. I'm a bit afraid to touch this part in case it's still charged. Although it could be fake though, because what FLEXTRONICS does is they do have black boards, right? And none of this weird glue going on. So yeah, this might be a very, very good fake charger. I honestly, yeah. It might be a very good fake charger, but why would you do a very good fake charger? Would be my question. It wouldn't make any economic sense to go that route. And yeah, it doesn't have the gray going all the way through, so it's definitely a different build. But it's very nicely done. I mean, this plastic is thick as fuck. What is this? Polycarbonate. Thick and strong. Yeah, so I think all we can do now is hook some wires onto this, let it cook for a bit, and then check what's heating up. All right, we're back, and I had another closer look at this, and it is 100% not genuine, right? So I don't think FLEXTRONICS actually did this. First of all, due to packages like this one appearing, I forgot the name of these. We have Capxon caps floating about, right, instead of SMD components. So this is very nicely done, right? It's not a bad attempt, but it's definitely not genuine. And you can see all the SMD parts are not very nicely populated right there. A bit misaligned and stuff, and you have solder bridges over here and over here. But these seem to be by design, but still, and then glue residue. So this is definitely a very good fake. In a tiny bit, we'll take a look at a bad fake, and I'll pop up a video of how the actual FLEXTRONICS one is supposed to look. But yeah, so basically, we can have a look, have it plugged in, and have a look and see what actually heats up. So I have done this. This part was stolen from Big Clive, so it's a Cliff quick test. Very nice. It keeps everything separated, and then when you close it down, it does connect these pins. Alright, this isn't touching much. Let's see if it... Alright, that's fine. So I've stuck this macro lens, which has this stupid 3D print, which doesn't hook it on all the way. It's massively retarded, but anyway. So we can get in way closer now. And... yeah, what is that? We actually hold it on the... separation is quite good, first of all. You can see there's this huge gap below 2011. And so that looks fairly decent. And yeah, touching this should be equivalent to touching your iPhone, which is usually made of metal, so quite dangerous using fake chargers. And so we have a hotspot over here. I don't know what exactly that is. Oh, it's that transistor package. It's one of them. So it's probably the main switcher MOSFET or whatever they're using. Anyway, so let's get this lined up. And we shall see that these resistors here, these two are the ones that are burning up a lot of power. So they're hovering at what? 37. So I think that this is the area where I saw the hot spot, right? And so I'm pretty sure these are the problem. And I've just plugged it in and they are heating up. Let's see what kind of voltage we get on them, and then we'll take this out of the mains because it is somewhat scary. Yeah, so these have the full mains across them. And they are... so right, full mains rectified, 300 volts, let's go. And 2 times 620K. So that would be 1.24 mega ohms. All right, so that, what kind of dissipation will we get? So I is equal to V over R. And so I would be 300 divided by 1,240,000 ohms. So that is 300 divided by 1.24 thousand. No, actually million. So 0.2 milliamps at 300 volts is equal to 0.072 watts. So yeah, that is, yeah, 1/10 of a watt. Not a lot, but yeah, significant, right? So those are burning up quite aggressively. Let's see if they've continued warming up. And keep in mind, this is in free air, so yeah, no, not a lot hotter, but right inside this thick plastic shell, they will gather up a bit more temperature, right? Yeah, so let's have a quick look at one of my most, let's take this apart. The fakest charger I found is this one. And this was a piece of junk. So this actually had a weight inside to make it feel more robust. The board was very minimal. And the transformer was probably shit. I didn't unwind it because, yeah, there's no point. But yeah, even these posts you see are, yeah, a bit lower quality than the ones we've seen. Although I didn't Dremel this as far. So anyway, But yeah, this is super fake, and I'll pop up a picture of what a proper one should look, so you can see that the board is and then all the components are SMD, everything is gunked down, everything is properly aligned, there's no glue residue and all that shit. So yeah, I mean, this was a good charger, but in the end, you never know how good the separation is on the, on this transformer, and if some windings touch and anything becomes live, then you have your whole phone being basically referenced to live. We have this Y-class suppression capacitor over here. You don't know how good this one is, right? And this, by design, right, links high side to low side. So yeah, I don't know. It's good enough, it gets the job done, but especially with metal phones, I really wouldn't go near these. So I'm glad I've noticed that this wasn't actually a legit charger, and I'll be replacing it. If you have any questions or similar stories, let me know in the comments, and have a good one.